Hello and welcome to ESM 101. This is a series of 6 presentations that I'm going to walk through that goes into the background and into a lot more detail around how and why and what we can do with data, log data and events as they go through the HPE ArcSight ESM or Enterprise Security Manager solution. This is very much tied to the 101 document that's available from the website and also Protect 724 as well. So if you haven't come across that, I'll make sure there's a link to it in the description for this as well. But this is like I say, it's a 6 presentation session where I'm going to be digging through in a lot more detail around what are the various components, how are they operating, and why do we do things in a certain way. Now, without further ado, let's crack on with this first session. So this is the first of 6, and in this particular session, I'm going to dig into what we call the event schema and the event lifecycle. What does that mean? Well, what I mean is, what is an event? What is the data? What is the log information? What's the schema? How do we describe that? What fields are we using? And then what is the life cycle that that event goes through? How do we process that? And at what point do we do the processing? Because it's a really useful thing to understand. Where are we doing? What are we doing? And why are we doing that as well? So, without further ado, let's get into the event schema itself. So it's worth noting, and I'm not going to go into the full detail here because it has evolved over time. There are a certain schema involved. It does vary a little bit with versions that you have as well. So I'm not going to go through every single field and so on. But what I will do is I'll go over the overall overview of what's involved here. So if you have used the ArcSight ESM solution at all, you would understand that there are various fields that we can see, we can get use of within the solution. And it's worth noting that there are 17 different groups of those. So there's the root, which is the top level. So you'll find things like the name field is in there. There's the category, which defines one of the categorizations that apply. So what is it? What's it relevant to? What's the impact and so on. So you'll have the category group. There's the threat group that was around the numbering scheme for the particular event. There's the device. So what is it? Device product, device vendor. That's the common ones that most people will come across there. You have the attacker and target. Now, notice here that they've got stars on that one. That's because it's a derived one. And I'll come back to that and explain that in a minute. You have the agent. So how did we collect this? What particular component did we use to collect this data and what is its name, what its location and IP address? The source and destination. So where does it come from and where is it going to? That's very much network focused. We have the file. So is it referring to what is it, a file being processed? Is there something going on? And then there's the old file. There's very specific use cases and circumstance there as well. Then there's a request. It's typically focused around things like the request URL and so on. But again, that's a derived one. So we'll come back to that one in a minute. We have the original agent. So if we're forwarding through multiple connectors, which again is a perfectly viable architecture, you'll find that there'll be an originating agent and then that goes through a forwarding agent. So you'll have multiple layers of those so we can track what's going on. Same goes with the final device if we go through multiple devices there. We have event annotation, which refers to the ability to annotate the event individually. So as an analyst, you can sit there and go, I've observed this and make changes and update the event accordingly. And then finally, in the last 2, we have device custom and flex. They refer to flexible fields that we can use to map data that doesn't match any of the other schema groups. So typically that's for custom application to devices that we want to put extra information in there as well. But like I say, the schema, which is well over 200 separate fields, fit into these schema groups, and then we can start to understand what's going on. So I mentioned this a second ago. We have derived fields. So these are not set at the connector level. So a connector or a smart connector is typically how we're receiving the data and processing the data, and as it goes towards the ArcSight ESM solution. But normally these are derived from another field within the system. So in the case of attacker and target, a really good example, they're typically based on the source and destination. So typically when we're talking about security products, the source of an attack is by definition, that's what it means. It's the source, typically IP address, and it's the attacker that's initiating an attack against a firewall or a server. And again, the target typically means the destination. So what does it mean as part of that? And we've got another example here with the request one. So typically request URL host, port, and so on, they're derived from the request URL itself. So again, this is a really good example of some of the parsing and normalization that we're doing that actually allows us to break out some of the field information so we can get to it quickly and easily. So things like the request URL is the complete protocol : / the host, if there is a username, ports, and the actual query element of the URL that's used. Now we'll be breaking that down. So typically that's going to be like a proxy server or something. We'll break that down at the connector level, and we'll break it down into the individual fields. So you don't set them, the system will break it down for you as part of doing that processing. So it's a nice way of doing it, a nice simple way of doing that derived field set. In the case of the request URL, you can set that at the connector, or you can do a derived, but you can't do both. So if it's a derived field, then it'll break it down for you, or if you set it, then it's fixed at that point. So just bear that in mind. The attacker and target, again, typically derived from the source and destination. So let's dig into that source and destination thing for a second, just so we get a better understanding of that. This is a logical way to describe the threat direction. So we need to understand who is initiating the attack and who's the recipient of the attack. That typically is source and destination, and it maps really well. There is an example here, and please do pause and go through that example to make sure, but there are going to be scenarios where, for example, the actual source of the data is the attacker itself. So there is a mechanism with an ESM, and it'll do that dynamically, and it'll adjust the target and would be the destination, and the source would be the alternative way around, specifically anyway. So like I say, if you want to go through the details and understand that, that's great. Please do pause and just go through that. But just note that typically the attacker and target map directly to source and destination, although they might be inverted in certain scenarios. Typically that's based on IDS, IPS events where we know that specifically. But do note that Logger and also Investigate do not have fields for attacker and target because it doesn't have the derivative technology for it to understand whether it's relevant the other way around. So if you're going to do a search with regards to attacker and target on Logger, you must use source and destination fields instead. It's just a particular note, but in most cases the attacker and target will be the same as the source and destination. But just bear that in mind, it's a derived field, so you cannot set that at the connector level. Then we talked about the fields that are processed by the framework. So there is a framework that we use to collect the data. That's the Smart Connector framework. And that's the mechanism we use to collect the data that we want to feed into ESM from a processing point of view. Now, some of that data is automatically populated for you. So things like the original agent, if we're forwarding through, are set at the framework. So you can't set those. Don't worry about those. Those are set for us, which is great. Other information like categorization is normally defined as part of the parsing process, and they're set values as that as well. So you define the categorization and it will apply that categorization, but you don't need to specifically do any processing for that data itself. And then other fields that are processed at the manager. So that what we mean here is that are processed at the ESM side of things. So the threat calculations and the event annotation. So the threat calculations are done on the threat level formula calculations, so that's a priority and so on. Those are applied and derived values when doing a calculation with an ESM. So you do not set those, and we do not understand necessarily what the full set of that information is at the connector frameworks or at the processing level. And again, annotation is done at the ESM level. So as an analyst, I can go in and I can add additional information to the annotation. That is then persisted with the actual data. So it stays with the data itself, stays as part of the schema. But I don't get to set that anywhere else. I actually have to do that myself as an analyst. It makes it obvious at that point. There is multiple timestamps involved here. So we've got what's known as the device receipt time, the start time, the end time, and the manager receipt time as well. So it's worth just very briefly digging into those for a second, just so we can understand this. So it's critical that we need to understand what these times are. So let's start with device receipt time. That's the time that the system itself that we're collecting the data from receive the event. So, for example, if it's a syslog server that's forwarding some data on, that will have a timestamp, and when it receives the data to forward it on, it will typically timestamp that with the time that it thinks it's received the data. That differs from what we call agent receipt time, which refers to the time in which the Smart Connector framework received that event. So in that case, there could be a very small difference in that. If there's a very large difference, which we will automatically note and generate an event to say that, but if there is a little bit of a difference, then it's worth bearing in mind how that communications is going on. That differs to the manager receipt time, so that by the time it comes through and is received by ESM, there may be another small time difference. If there's a large time difference, that gives us a great example to allow us to identify if there's some caching or if there's some delays in getting the data to us. That could occur and it could be normal, but it's worth understanding what it is. And then finally, we have the start and end time. That is typically the actual source has generated a 2 timestamps. So we need to have this mechanism. A really good example is if you're doing a vulnerability scan. So there'll be a start of the vulnerability scan time and there'll be an end time that it finishes. So we need to track and understand that, so how that's going on. So those 5 timestamps are critical for us to understand and process and store with the event schema. Remember, we're talking about the event schema here. And they could be different, and that's okay, but we do need to have an accurate timestamping of the data to understand that. So let's go through the event lifecycle now, just very briefly. So it's processed in what we call 7 phases, and it's pretty obvious what we're doing here, but it's worth understanding that there's different parts and components of the overall system that we're going through. So the first stage is to have the data collection and event processing. So we're getting the data in from the log sources and doing some event processing. The next stage is we're doing a network model lookup and priority evaluation. So we're trying to apply this to what we think is a logical setup of what the network is, with some naming and structures, and so we can understand what location, what environment, and so on. But then we need to do a priority evaluation. So do we increase or decrease based on that model? Is it a critical server? Yes, increase the priority. Then we need to do the correlation itself. Now notice here, with the event lifecycle, correlation is only one phase of what we're doing across here when we consider the lifecycle of an event through the system. So we do some correlation there. We now then go on to stage 4, which is the monitoring and investigation. So something has occurred. We need to monitor and understand what it is, and then allow an investigation around that from an analyst. Then we move on to the workflow and how that touches on the events themselves. So again, I mentioned that very briefly before. Things like annotation is a really good example of how we can add data to the individual events as part of this workflow mechanism. Then we have incident analysis and reporting. So clearly we need to be able to report on the data and provide analysis around what we've received. And then finally, as the event is coming towards the end of its effective usage, it will then be archived into an external storage environment so as we can store the data for an extended period of time. So we can see that, like I say, correlation is just one stage of this, investigation is just one stage. An event would pass through all of these 7 stages as it's being processed. So let's go into stage 1 specifically. Let's have a bit more of a detailed look at this. So what we do have, this is where the connectors come in, so the Smart Connector framework, and they're doing a number of things. So they're collecting the actual log data from the sources, and it's doing a number of conversions. It's converting that raw data into normalized events. It's tagging that data with additional event categorization, some potentially customer information, as well as the zone. Where did it come from? What's the logical setup of the network involved? Maybe we're doing some additional processing, for example, filtering, so excluding some data we don't want to have in the data. Alternatively, maybe we're aggregating, so we receive 10 events of the same thing. Let's just have one event with an incremented count of 10. It's a much more efficient way of doing things. We need to also categorize that as well. So is it an authentication attempt or not? And then we forward that data on. So in this case, it's a very simple environment. We're just going to take that data and forward it on to the ESM solution. But of course, we could forward it to Logger as well. So the data collection layer is quite an important one, and we're going to spend a little bit more time just digging into that a little bit more shortly. The next stage is the phase 2, so the network model lookup and priority evaluation. So in this case, we've received that process data from the smart connectors. So we've got some information, we've got some parsed data, but we need to tag that with and look up in our network model what is the additional information. So is it from a production network? Is it from our test network? Is it from our location in Hong Kong? Or is it from our particular headquarters data center in Dallas? We can apply that information. We do that lookup. We add it to the event information. We can also do that priority evaluation. Again, like I say, is it a production server? If so, yes, increase the priority of the event accordingly. And we're evaluating that base events to apply that data. Then we subsequently ensure that we are writing that data to the database as well. So now we get to phase 3, which is the correlation evaluation. So we're doing this in memory, and it's critical to understand that this is occurring as we're processing the data, as it's in the memory itself. So this is not done through searches, it's not done through any database queries or anything. So what we're doing here is we're discovering that relationship between the events, and we're trying to infer the significance of those relationships. Frequency, process, sequence, and this provides us with a framework to take an action. So we're looking at those normalized, prioritized events. Remember, we've got the event categories, so the actual fields from the original raw data, we've processed it. We've got that applied with a network model, so it's from our critical systems talking to our data center 3, for example. We've got the calculated priority. Well, this is a critical system that's in the communications, so therefore we've increased that priority. Then we can do some processing within the correlation engine around filters, rules. Data monitors our statistical way of doing correlation. That will then generate a number of things here. So we can see that there are correlated events. So we will, in some cases, create a correlated event to say this particular relationship has appeared. We create additional ArcSight events. For example, if we've added some information to an active list, we'll create an audit event to say that we've added that information. That's not a correlated event, but it's an audit event. And then finally, we'll have the normalized prioritized events as they carry on being processed as well. Which then takes us on to phase 4, which is the monitoring and investigation. So now we've taken those events themselves, the correlated events, the audited events, and like I say, the ArcSight events, and then finally those prioritized and normalized events from the actual log sources. We can then put that through some additional sets of tools that will interact with those events. Remember, we're talking about the life cycle. So what happens as that events pass through the system. So in this case, we'll look at the events through, say, for example, active channels, looking at our primary investigation channel, for example. We might want to put those events into a dashboard. Again, this could be a combination of both correlated events, audit events, internal ArcSight events, as well as those normalized events themselves. And then additionally, we want to use things like query viewers to do a fast way of generating a particular dashboard element, component, or report as well. So we can look at and investigate through that data accordingly. We also want to have a way of doing the workflow. So again, we're taking those events as well, and we can add, for example, stages. We can add those events to cases. We can even update them and annotate them and put them into a knowledge base, and also trigger notifications, whether that's emails, pages, SMS messages, SMTP, or even syslog messages as well. So again, we need to have a framework to understand the workflow and how those events could be tagged to other systems and components like cases and stages and allocated to users, but additionally how those events can then be sent out to external systems to say this has occurred. Then we get to phase 6 side of things, which is the incident analysis and reporting. So we do need to have a way of providing an effective reporting mechanism, be able to identify what overall trends are, and then if we want to, even use things like pattern discovery or threat detector to actually identify some patterns that are new that we haven't identified before. So again, this is the phase 6. This is how we're interacting with those events and how we're accessing and viewing the events themselves, which then leads on to into phase 7, which is database partitioning and archiving. Now, it depends on what version and what platform you're using here, but there are ESM versions that run with Oracle, and there's ESM versions that run with what we call core database. Now, in the case of Oracle, it uses partitions which are moved between states. So we move them between online hot to offline cold. With the core database engine, archives are created a daily basis, and that is exported to an external storage location. So there are two slightly different ways of doing things, but in essence, this is the end of the life cycle of the event from our point of view, where we've now got the database, we've put that data, we've processed it, and we've done all the other good things beforehand, but we've now placed that data into some sort of external storage, into these archives or database partitions on external storage. So that quickly just walks through the overall process of how we're doing things, of how we're stepping through, and what the life cycle is on a very high level of the events as they pass through the system. So that sums up the first stage of 6 presentations around this ArcSight ESM 101 training session. Thank you very much.